Hello? Okay. Hello to those people that decided to go flip burgers instead of coming to school this day. All right. No shade in any direction. Okay. All right. Comparison test. So now when you're, we're going to use comparison test for convergence and divergence to use the limit comparison test. Okay. All right. So basically, theorem, comparison test for convergence. So if 0 is less than a of k, and then that's less than or equal to b of k for all k, then, and b of k converges, then a of k must also converge. So let's think of it like this, okay? We have a person in this classroom, okay? I will call them subject 6, okay? Subject number 6 is less than, so not as tall, as another person. But do we know how tall that other person is? Yes, that person is 6 feet tall. But by comparison test, since I don't know how tall subject 6 is, but I could say in a comparison, since I know that the other person is 6 foot tall, in comparison, I can logically say subject 6 is less than 6 feet tall, right? Yeah. Now, we're applying it to convergence and divergence. So if I'm comparing it to a convergent, so therefore it must also converge. Make sense? Yes? Okay. All right, so let's take a look. It's important to remember that that the early terms have no effect on the convergence or divergence, because remember, the first terms don't matter if it's the pattern after that we're looking at, right? Okay, pattern after, because a lot of times we'll get like the first one or the second one that will not be the same or will not fit my series. Then I'm going to have to actually do a little bit of creative math to make it happen. All right, has no effect on convergence divergence in the series. In fact, comparison test for convergence is true if 0, okay, is less than a of n, which is less than or equal to b of n, for all n that is greater than or equal to n, which n is subtly a selected integer, so from some point that I have. We use this next example by ignoring the first term. Okay. This one, k to the k. So by ignoring the first term, I'm going to be able to look at it and say like, okay, so how can I rewrite this? So think about the test that I did the other day. Think about the test that I did the other day. What would I do to do that second one? Can I rewrite that second term? Say yes. Yes, I could rewrite the second term. How would I rewrite the second term? Can I rewrite it like this? Right? So I could rewrite that one to there, right? So technically, this is still going to be right here. It's 1 over k to the k, right? It's still that, right? Because the first term, 1 to the k, is just still going to be 1, right? No matter what the exponent is on that one, it's still going to be 1. So in this case right here, I want to rewrite this term right here. So I'm going to make an a value out of this. Do you remember that yesterday? How would I make an a value out of this? It would be 1/2 to the 1, right? Yes? Okay, so it's going to be times another value of 1/2 to the, it's going to be 1 right here, right? But in the terms that I'm talking about here, it's basically going to be to the k, since it's going to be my second term, right? So it's going to be k minus 1. Isn't this my second term? Yeah, this is my second term, isn't it?
Yeah.
So I'm taking out from my second term because it would be from here where k is equal to 2 starting out. Because we're ignoring this first term, so it's not going to give me what I need. Yes? Okay, so what is my r value here? Okay, so what does that mean? What does that mean? Take out your notes, please. Everyone, take out 8.2.
Yeah, it's convergent. Like he said, it's less than 1, so it's convergent.
Okay, so that's going to converge. So now, what is my a value here? 1/2. Okay, so I'm going to compare it. I'm comparing this right here, starting with here. So this is basically, I am going to, it's 1/2 times this, right? So I am going to compare it to what I know of 1/2 of k minus 1, since it's going to be that times this, right? So since I'm comparing it to this right here, that part right there is going to be convergent. Yes? So that part's going to be convergent. So since I'm going to compare the whole thing to a convergent, so now this piece is going to converge, and so therefore the whole thing has to converge. So it's a convergent, and I don't know because I'm ignoring the first part of it, and I'm actually just rewriting it using the second term instead. So it's eventually going to converge because of what we have here. Yes? Okay, good. All right, comparison test for divergent. Okay, so again, same thing. C of k is less than or equal to a of k. C of k diverges, then the whole thing diverges also. All right, let's do some effing that.
Yeah, I was gonna say these are pretty bad.
It's what?
It's been pre-effed.
It's been pre-effed? Can you F it? What? Huh? I don't know that. All I hear is like just sounds. Like all I hear from you is just a vowel.
Yeah,
Like,
exactly.
is there like a word to go along with that?
It's already F, so why are you asking us to F it?
Because I want that F out. Take the F out. So it's going to be 1 over.
Yeah, that's what I was trying to say.
Sure.
All right, so let's take a look at what we have here. So on this one, let me make sure. Oh, I was on the wrong example. Make sure I do not screw this one up.
We can make that 1 over k and not k plus 3 over k.
Yes, 1 over k, because I'm factoring out a 1 from the top.
Okay.
Yeah. So good question though. So I just want to make sure I don't screw this one up. All right. So because of this, okay, this is supposed to be, because of this right here, it's going to end up becoming less than 1 over n, right? Less than or greater than. Hold on. Crap. Nope. God. Dang it. Okay. It's greater than 1 over n. Sorry. Okay, yeah. It's going to be greater than because we know that this piece right here is what? That piece. What do we know about that piece right there?
It's equal.
So it's basically the 1 over n, right? So if I'm changing all this to n, so let's take a look. So it's going to be 1 over n times n plus 3 over n plus 2. It's going to be greater than 1 over n. Okay, so if it was less than 1 over n, this would, that should converge, right? Okay, so now, what do we know about the 1 over n? It's what?
Harmonic.
There's my harmonic, right? That piece right there is harmonic, isn't it?
Yeah.
Since it is going to be harmonic times whatever this is, so that's going to be more than, what am I going to have here? Because these values over here are going to end up becoming, just whatever times a harmonic series. So therefore, this one's just going to be even more, right?
Yeah.
Even more divergent.
Yeah.
So when I'm comparing these right here, because this is harmonic, that means that all of this right here is going to diverge. So I'm comparing it to a harmonic, knowing that it's going to diverge. I get the 1 over n right there, so it's going to be greater than. So as I'm plugging in my numbers, all my numbers right here, this one's going to end up becoming times. So if I were to take this limit right here, it would go, this one right here would go to infinity, wouldn't it? Okay, infinity over infinity, which would basically come out to be 1, and this is my harmonic series. No? Maybe.
Yes.
Okay. Can someone turn the fan on, please? Because I don't want to listen to that thing all day. Just hit the power switch on the left. It's on the power strip. Power strip? There we go. All right, theorem. Just the red button. There we go. Okay. Suppose the sum as k equals 1 goes to infinity a at k, and the sum of b at k are both series of positive terms. Okay, if n goes to infinity, as n goes to infinity, of a over n, a of n over b of n is equal to my limit, then my limit is going to be somewhere between 0 and infinity. What does that really mean?
It's a real number.
It's going to be a real number. It's going to exist, right?
Yeah.
So we're talking about some positive limit number that I'm gonna get, like some real number, okay, not like imaginary or
Why
anything.
can't it be negative?
Positive terms, because I start with k equals 1, right? Okay, of k equals, that's what I'm saying, because if remember when we're doing the I think it was 8.1 when I'm trying to like sandwich them into certain things, right? When I talked about a certain epsilon, after a certain point, that epsilon, everything is sandwiched in between those, right? So it's bounded above, bounded below, and if I'm talking about numbers on the other side of that, so other side of that, those are outside of my epsilon, right? They were outside of the epsilon, so they weren't fitting in there, but that's why it starts at a certain term, and that term is going to be bounded above or below and or both. Does that make sense? Okay. All right. Then both series converge or both series diverge. Limit comparison tests, okay, gives no guidance. Okay, if this comes out to be 0 or infinity. So if my limit comes out to 0, so guess what? That sucks. Okay, so that one doesn't work. Okay, or if I get infinity, guess what? Doesn't work. So right here, and or does not exist. So it only works when I go to a limit between 0 and infinity to some real number there. Use limit comparison test, converges, diverges.
Let's F it this time.
Yeah, let's F it this time. Okay, so if I F that, so I'm going to take the limit, right?
Yes.
So let's go ahead and take the limit. So I think I'm going to change these to x's, right? I think I'm supposed to change the x's. I'm going to do n's instead. All right, so we're going to do this. So it's going to be so we're taking the limit as n goes to infinity. Yes. All right, so now we're gonna f that. So let's f the out of it.
1 over n.
Okay, so it's gonna be the limit as of 1 over n, right? Okay, times the limit of right? So now, it said limit compared to test. So how am I going to rewrite this now? So I have my everything written out, right? So what am I comparing this to? So I'm going to compare it to convergence or divergence, right? Okay, what am I comparing it to? Okay, let's do 1 over n, right? Okay, so let's compare it to 1 over n. So I'm going to compare it to 1 over n. N plus 1. Dang it. Brain work. So, in those comparisons, let's go ahead and actually take the limit of each one. Ah, why is this one backwards? So on this one, I'm going to test to see if it's going to converge. If it doesn't converge, because my, right here, it's going to be less than. No. Okay, so let's go ahead and take the limit of that. So from the 1 over n, so as n goes to infinity, what do I get? I get 0, right? So limit. So from this one, it's going to give me 0, right? B of n. So B of n is my bottom. So I'm comparing it to some number on the bottom, right? So my B of n is going to be the limit as n goes to infinity of 1 over n, and then the limit as n goes to infinity of my 1 over n times 1n plus 1 over n plus 2. So on the bottom, we know as n goes into infinity, that one right there, it's going to go 0 there, right? Yeah, so 0 right there. I'm automatically not going to be able to get that one. Okay, because I'm comparing it to that because of the... I have it on my notes, but I totally forgot what I was doing this morning. Rewrote all my notes. B of n, 1 over n. Oh, okay. I wrote it wrong. That sucks. Okay, same thing. Since I have this, they said do the math on it first. Right? We're still doing the limit. So it's going to multiply by the reciprocal. The reciprocal of the bottom is going to be n over 1, which is now going to give me the limit as n goes to infinity of n plus 1 over n plus 2. So as those things right there race to infinity, I get infinity over infinity. What's infinity divided by infinity? No, I'm not checking for L'Hopital.
I know.
So what's the coefficient right here? What is the coefficients? 1. Remember, do they have the same degree?
Yes.
Same degree, right? So as this is going to infinity, the same degree, my limit would be 1 over 1, so this is going to give me 1. So what did I compare this to? I compared it to what? 1 over n. So I compared it to 1 over n. What was 1 over n? 1 over n is I compared it to a harmonic divergent, right? Say yes. So if I'm comparing it to something that's divergent, does the test still stand? Let's see. Right here. Okay, comparison test gets guidance. So right here, both series converge or both series diverge. Since I compared it to a divergent, the 1 over n, did I get a, where's it at? Positive term, so the somewhere between 0 and infinity. Did I get a limit somewhere between 0 and infinity?
Yes.
I do have a limit between 0 and infinity, so therefore, I got the number 1, right? So 1 fits into those bounds between 0 and infinity. So, did this test work? Yes, it did. The test did work. I was comparing it to a divergent test. So the test did work. My answer works, so therefore this thing is divergent because I got a number 1 out of it, which is between.
So if you were to compare it to a series that is convergent and it got you a number between 0 and infinity, then it would be convergent.
That would be also convergent. Yes.
Yeah.
So it depends on what you're comparing it to.
Yeah. Okay, I see that.
So if you're comparing it to convergent and your answer lies somewhere in between these two, it's going to be convergent. So now what if my answer lies outside of that?
It's not convergent. I mean, it's not divergent.
No,
Oh,
the test doesn't work for that one.
yeah.
Test doesn't work for that one.
There's no limit at all.
Okay, so what other ones would not work for that? So if my limit came out to 0, my limit comes to infinity, or the limit does not exist. No guidance. This only works here. Okay? It only works for these type of problems. So it's here, here, here. No guidance. So that means that test fails. So the test fails. So you don't really know what you're going to get. So you have to try a different test. You're going to have multiple tests later on. We're going to have, power series and all kinds of weird stuff. Okay. Comparison with a P-series test. So let's take a look. converges or diverges? All right, so now, if this is going to be a p-series, remember the p-series from yesterday. All right, so I got some issues with this. So what do I have to do? For it to be p-series, okay. So, for that to work out, I gotta do some factoring of this little nasty, right? Okay, because it's not in the right format, is it? So I'm gonna take out that k to the 3/2. So I'm gonna rewrite it as 1 over 2 n to the 3/2 plus 5. I'm gonna factor that n out. Okay? I'm going to factor it out. So I'm going to say 1 over n to the 3/2 times. Okay, so what's going to be left right here? If I'm taking it out of the first term, there's going to be a 2 plus 5 over n to the 3/2, right? Yes? Okay, so let's go ahead and do a little bit more creativeness here. Okay, so now I'm going to be able to take out that 1 over n to the 3/2, right? Okay, so since I'm going to be able to do that, let's see. Let's clean up this other part over here. So, common denominator, right? Hold on, I might be able to get away with it not. 1 second before. Yeah, okay, let's clean up the bottom. So right here, this is going to give me common denominators n to the 3/2. So this is going to be just this piece. So it's going to be 1 over n to the 3/2 times, okay, 1 over 2 n 3/2 plus 5 over n to the 3/2, right? Okay, clean up the fraction over fraction. So multiply by the reciprocal, so now it's going to be 1 over n 3/2 times n to the 3/2 over 2 to the 2n 3/2 plus 5. Okay, so now let's take this piece right here, the P series. Okay, from this one, from my P series, I'm able to go right here. Okay, P is going to be between 0 and 1. Okay, so it's going to converge if P is greater than 1, diverge if this is. So now, using that, remember we talked about this, so this was right here. Now we're doing a convergence test right here for this. So now I have this in the right format for what I'm going to have here, right? I'm going to have the right format. So let's take a look back over here. So what is my p-value here? 3/2, right? So from this, it's going to be 3/2. So this is going to give me my p. So it's going to be 1. What is it? 3/2 minus what? 1. And this one right here is going to be the sum, right? So this thing right here, actually let me rewrite. I'm going to just use a symbol. So my sum, and that's going to be what? Okay, remember it's S of 1. S of 1. So what would be my first term? 1 over what? One over 7, right? Hmm?
The integral from 1 to infinity of a function is where you have a 1.
Did I do this one wrong?
Because it has to be some non 1.
Oh, you're right. Dang it. There's so many tests I keep getting confused when I'm doing this, and that sucks because I'm supposed to. Can't be confident and be like, oh yeah, I use this test when I use the wrong test. So we have A of n and B of n. So we're comparing it to, so not this one. Not this one. You were right. All right, so I have I'm going to compare it to this piece right here. You're right. Limit comparison because I was using the other one that was yesterday's. This one's today's only. So I'm comparing it to this. That's going to be my B of n. So it's going to be the limit as n goes to infinity of 1 over n to the 3 halves times n 3 halves over 2 and 3 halves plus 5 over 1 over n 3 halves. All right, let's do some math. Okay, crap. Get reciprocal at the bottom. So, reciprocal at the bottom. So I flipped over algebra, right? So I took this, I multiplied by the reciprocal at the bottom of this. Right here, bam, bam. So I'm gonna get this, right? Do they have the same exponent? So by taking the limit as n goes to infinity, I'm going to get what? 1/2. Now, is 1/2, where's 1/2 going to actually be there? Okay, greater than 0, less than infinity. Did I compare it to a convergent or divergent? This one's going to be convergent because the P series, right? P is going to be greater than 1, right? So we compared it to this is a convergent. Okay, and since this one right here is going to be between, so this is, yes, this is the test works. So yes, that works. Yes, I compared it to convergent, so therefore it is going to be convergent.
Nice.
Okay, yes. I'm trying to rush through this, so. All right. Okay, don't forget, like, share, and subscribe. All right, people, since no one else is in here, I'm going to do this all by myself. All right, so I'm going to see if this is going to converge or diverge. So let's take a look and try to actually take some of this out. So I'm going to turn these into n's, and then I'm going to take it out. So I'm going to fact out the k to the 1/2, so it's basically going to be n to the 1/2. So I'll rewrite it as 3 to the n 1/2 plus 2 over square root of n cubed plus 3 n squared plus 1. So we're going to take this, so I'm going to factor this out, so I'm going to come out with n to the 1/2 parentheses. As I take that out, it's going to be 3 plus 2 over n to the 1/2. Okay, don't forget, these are negative exponents, so I'm going to deal with that here momentarily. So now all this, so as I factor that out, I could factor this out, but it's going to be a different radical. So it's all going to be a square root, which would be to the 1/2, but then I have my exponent here. So as I factor this out, I'm going to show you before I actually do the math. So it's going to be n, so it's n cubed, parentheses, 1. So if I distribute it, you could actually see it later on. All right, and that's going to be plus 3 over n, because this is going to be, I'm dividing by n cubed. So since I have n squared here, I'm divided by n cubed. So let's just leave n there and plus 1 over n cubed, because I have all that inside there. So now I could write this out as two different with the exponents, with the exponent of 1/2. So this is now going to be n to the 3/2 parentheses 1 plus 3 over n plus 1 over n cubed to the 1/2, like that. So I'm going to erase what we have right here. There we go. All right, so I'm going to compare this to, let's take a look. So looking at this with my leading coefficients, I'm going to have n to the 1/2, n to the 1/2 over n 3/2. Okay, now as I take the limit of this other nasty piece right here, I have to look at the leading coefficient. So, all right, so as I do here, so my leading exponent, so I'm going to plug these in so you guys could actually see this, because this might be kind of confusing. So this right here is actually n to the 0 power. This right here is going to be 1 n to the 0 power also. So to the 0 power, so now these are all negative exponents. So if I were to rewrite this, let me just rewrite the top. It's going to be 3 n to the 0 power plus 2 n to the negative 1/2 over my n to the 0 power plus 3 n to the negative 1 plus n to the negative 3 all to the 1/2. So because I'm looking for the leading coefficient, that means the greatest degree. My greatest degree here is going to be 0. So I have negative numbers and I have 0. So the greatest is going to be n to the 0. So therefore the limit, as this one right here goes to infinity, for this the limit as n goes to infinity of this is going to be 3. So I'm going to get a limit of 3 for this piece that I have right here. So I'm going to back up a little bit, so I'm going to clear this off so you could watch the video and back up the video then. All right, so this is going to be times 3 where I have here. So now I'm going to compare this. Let's clean this up. So that's going to give me 1 over just n. So now 1 over n is going to be a harmonic, so therefore that is going to be a divergent. So I'm going to compare this one to a divergent. Okay, so I'm comparing it to divergent. So I have 1 over n is going to be my b value. Insert page after. So I have, let me see, 1 over n here. Then I have my the top, which was, gotta back up. Dang it. Okay, so that's going to be 3 plus 2 over n to the 1/2. So 3 plus 2 going to be plus 1 plus 3 over n. Alright, and this is my 1 over n here, all over. Now, so this is going to be my a of n, and this is my b of n. So this is what I'm comparing it to. I'm comparing it to 1 over n, my divergent harmonic. So from here, I'm going to go ahead and take the limit now. So as I do the algebra first. So I'm going to multiply by the reciprocal. So it's going to be times the reciprocal of the bottom, which is this. So it's going to be n over 1, which is going to be bam, bam, right there. So now those go away. So let's take a look. So now I'm going to take the limit as n goes to infinity of what I have here, which is going to give me, let's see, my 3n to the 0 plus 2n to the 1/2, negative 1/2, over 1 plus 3n to the negative 1/2, not negative 1, negative 1, negative 1, not negative 1/2. Plus n to the negative 3, all that to the 1/2, right there. So now, as I'm taking the limit again, so this is my n to the 0, that's 1n to the 0. Like that. So again, as I take the limit, as that goes to infinity, that's going to give me to 3, and my My 3 is going to be between 0 and infinity. So given my limit test right here, this one, since I compared it to a divergent, this one is the test works. So this is going to be divergent. All right, next one. All right, determine whether a series converges or diverges. So now on this one right here, this one is using a geometric series. Now in this geometric series, we're going to look at it and let's see what we're going to get. So it's going to come out to be as n gets really, really large. So if I rewrite this as 2 to the n over 3 to the n plus 5, as this gets really, really large, so as n gets big, so the 5 is just going to go bleh. It's going to go away, right? So as I'm taking this to infinity, 5 is going to go away. So the 5 going away. So I'm going to compare it to 2 to the n over 3 to the n, which is basically just saying that I'm going to have like 2/3 all to the n. Right here. So now this is going to be my geometric series. So now in this case right here, my p-value is going to be less than 1. The p-value is going to be less than 1. So since the p-value is going to be less than 1, so that means that this is going to be convergent. That's going to be convergent. So now I'm going to compare it to a convergent. So let's take a look. I have my... So let's set this up so it's going to be the limit as n goes to infinity. Let's do the algebra on this one though. So it's going to be 2 to the n over 3 to the n plus 5 over 2 to the n over 3 to the n. So multiply by the reciprocal. So it's going to be 2 to the n over 3n plus 5 over, no, it's not over, it's going to be multiplied by, sorry. Multiplied by times the bottom, reciprocal bottom, so that's 3 to the n over 2 to the n. So my cancel right here, so I'm going to be left with 3 to the n over 3 to the n plus 5. So now as I'm taking the limit of that, I'm taking the limit of that, so I have 3 to the n over 3 to the n, which should just give me 1. So using my limit comparison test, I took the limit, I'm comparing it, so I compared it to a convergent. My convergent comes out to be between 0 and, there's my limit, and infinity. So this one does work. I compared it to convergent, so therefore this one has to be convergent. All right, here's the test that we actually have to go for. Just a different series. So all the things that we kept talking about, referring back, I had to go over to 8.2 to pull out a couple of these, the harmonics, the P series, the series, if it's convergent, divergent. So all the tests that I have right there. So these are important to have, okay? And don't forget, like, share, and subscribe.